so much for the kind introduction. Thank you everyone for attending. Just kind of in the context of airport development, of course I'm going to provide an overview of Seerage, of digital remote towers, which is essentially our key product and innovation. But in the context of actual airport innovation and development, we wanted to kind of provide an overview how technology is crucial in terms of developing and expanding airports given the light of the growth of aviation. So in terms of my presentation, I'm actually just going to give examples of some of our current projects and kind of show how our technology is either enabling faster growth or the adoption of technology taking a key part in airport and ATC operations. So Seerage is a Canadian company. We are based in Ottawa, Canada, but we do have now several offices around the globe. We started almost 19 years ago as a systems integrator, and about 14, 15 years ago, we became a product and an innovation company, mainly bringing in intelligent video into the air traffic control towers, birthing the whole concept of remote and digital towers. We are also really pride ourselves more as an innovation company. About 4 or 5 years ago, we also brought in artificial intelligence into the air traffic control towers. So 2 key innovations in the space. To date, we have deployed our technology at over 40, 45 airports around the world, ranging from very small airfields to the largest airport operations, including Dubai. Like I mentioned, we are first in terms of bringing intelligent video and AI, and it played a crucial role in terms of enabling our larger airport customers dealing with the rapid growth, but also providing an environment where delivery of air traffic services and airside operations could be done in a much more efficient manner. Since 2010, actually, NAV Canada has invested in Seerage, seeing as a key in enabling and disruptive technology within the space. And 4 years ago, NATS from the UK has also taken stake in Seerage. So we're actually owned 50-50 by 2 leading global ANSPs. So in terms of our footprint, we are global. We're on 4 continents, of course, North America, Europe, Middle East, and actually Northern Africa, and Asia Pacific as well. So in terms of the technology, talking about remote or digital towers, what is that concept? In a nutshell, we're able to take digital technology using video cameras, video processing, and integration of existing airport and ATC systems and create environments for the delivery of air traffic control services and enabling things like automation around airside operations. So quick little video. This is, I think, from about 5 years ago here in the UAE. We deployed about over 200 camera sensors. And within our software, we're able to stitch up all the video and integrate that with the key air traffic control and airside operation systems, enabling operation centers to be deployed anywhere. We actually have an innovation lab. This is where the video's from, a cell phone video of a video wall, and it's actually landside. So we're able to bring in the customer and together develop new technologies based on our platform. The second big innovation that we're kind of bringing in, apart from being able to digitize the air traffic control tower and ultimately either replace towers or alleviate having to construct new air traffic control towers, is layering on more technology, again, to be able to deal with rapid traffic growth or increasing safety and, of course, efficiency. So our artificial intelligence platform is called AIMI, And in terms of bringing AI in the air traffic control and operational environment, we're looking at 4 key areas. Of course, computer vision, being able to extract data out of CCTV cameras or maybe our digital tower cameras that we have deployed. We're also looking at flight data surveillance, so being able to kind of look at that big data aspect of creating automation and predictability, again, to be able to land more aircraft or increase safety. Looking at natural language processing and other analog systems that are kind of today, where there is a lot of information that we can pull out of pilot air traffic control communications in order to build applications on our platform. And of course, in the future, we're looking also at incorporating weather, again, by having artificial intelligence looking at these 4 key areas, we're able to then provide a platform and an easy way of creating new applications based on technology to provide automation or enhance ways to operate airports. So I'll give some examples on the AI before we kind of go over into the project side. For example, tapping into cameras at the gate side, we're able to extract a multitude of information, and in this case, we were able to build an application that sits on our platform for monitoring the turnaround events. So in this case, we're able to feed key data into systems like ACDM to provide accurate status of turnaround events and enabling our customers in the airside, in the actual airside operations space, to be able to make better tactical decisions and planning. And of course, that transfers over to the ATC side for slot allocation and things like that. In Heathrow, we took a different approach where one of the first applications that we're looking at, again, this is training the AI, looking at video, but also integrating flight plan and surveillance data, and looking at the runway and the runway exits. So we call this system the hold line surveillance, and essentially what the AI is able to do is make a determination of when an aircraft safely vacates the runway. And this has a big application in terms of Heathrow's operation in what's called a tower in the cloud operation. This is when the air traffic control loses visual line of sight to the runway and the aircraft, where today the regulator actually imposes an increase of separation, given that there is no visual line of sight. But what we're doing is teaching the AI to determine when an aircraft safely vacates, and in those instances actually integrate the digital data, not the video or anything that you see here. It gets actually integrated into the air traffic control systems, and it tells the controller when it's safe to land the next aircraft. Ultimately, the business case here is reducing separation and low visibility procedures and being able to land more aircraft than they typically would in the status quo. Another application that we're working on in Singapore is actually taking large data sets of historical data and teaching the system and the AI essentially, oh, excuse me, I guess my video is not working, but we're teaching patterns to be able to predict conflict situations like an imminent incursion or an imminent go-around, and being able to then provide in real time information to the air traffic controllers to alleviate that situation or deconflict the situation. Again, it's applying technology to the status quo, where in this case, we're impacting not only efficiency by alleviating it to go around, but of course, a positive impact on safety. Some of the other applications we're able to build on this digital platform are automation applications. In this case, what we're doing actually currently here in Dubai, in Doha, and planning on actually deploying the system in Heathrow and potentially in Hong Kong, is utilizing video AI processing as well as logic and incorporating that into an automation system to control vehicle traffic on service roads that across active taxiways. Again, the status quo today, to keep on the light of safety, is vehicles would typically stop and queue up until they were 100% confident that it's clear to cross. In this case, the system's going to provide that intelligence and provide more throughput for vehicles going to the stands or to the baggage. In terms of remote and digital towers, one of our first successful certified systems was in Budapest. So the business case in the Budapest airport was actually the air traffic controller, or the air traffic control tower was nearing its end of life. So it has about 2 years left. 3 years ago, Hungarocontrol, the air navigation service provider, partnered with Seeridge to create a full digital visual control room at their headquarters, which is about 7 kilometers from the current airport. And this is a system that today is serving as a contingency to the actual tower. And then within the next 2 years, we're looking to expand the system and actually transfer the day-to-day control of the airport to the facility, where about in 5 years, the tower will be completely decommissioned. So just to say that at the current state, the technology is mature, it's certifiable. We work with several regulators around the world, and it's mature to a state where it's being adopted by ANSPs and airports globally. In Heathrow, together with NATS, we're actually looking at deploying the technology for a couple different business cases. I mentioned the one with enhancing the low visibility operations, being able to increase capacity in the current LVP ops. And the second, of course, is looking at the video or the digital system to not have to build a second tower for the planned third runway, which of course would be a huge capital expenditure, but the other saving is actually having a more streamlined and integrated operation. So not having 2 separate tower operations, but being able to bring this video technology either into the current tower or eventually not needing a physical air traffic control tower altogether. And what you guys are seeing here is actually a laboratory that we created together with NATS and Heathrow. It's in the actual tower building on the bottom floor. And our whole concept is to actually have a development and innovation lab that brings the users right next to the engineers. So the operations team comes down about every 2 weeks, and they feed in direct requirements. And through an agile, fast development cycle, our engineers are able to turn around those ideas into prototypes and reality, where the operation team can actually get a look and feel and validate the development and the requirements. So what this actually results in is a much quicker technology development, but more importantly, a rapid adoption of technology. And of course, by having the users and the developers closer together, by getting things like requirements and development done in a much shorter time, what we're able to field into operation is exactly what's required. And this is an ongoing cycle. So most of our big programs, they have this kind of innovation lab that's running in parallel to the operational system, where we're constantly looking at applying technology to operational issues and changes. So a digital tower doesn't have to have a big video wall. What you guys are looking at here is the temporary tower cab at Paris-Orly Airport, where we're able to distribute cameras around the airfield and then present that data to controllers in a hybrid model. So meaning they would still use the window, but in this case, the problem was that the temporary tower was too low. So the ground controllers actually lost line of sight to some key taxiways, to the stands. And from a regulatory perspective, without the system, they would have to lower the capacity of the airport by not being able to move simultaneous movements. by being able to provide them a digital replacement to the tower window, within 8 months, the system was able to be certified, put into operation. So when the main tower cab was being renovated and the operation had to be in the temporary cab, they didn't lose any capacity. And the result, now that the controllers are back in the main tower, they want the system, and they're keeping the system. We're building that on just because it was provided an enhancement to the tower operation through the window. Here in Dubai, we've been working together with Dubai Airports and partners Honeywell and NAV Canada for about 8 years now. Year on year, the system has been expanded and has several different use cases. One main one is actually looking again at those traffic lighting automation, where the service roads are crossing the active taxiways. So we have over 200 camera sensors for full airfield surveillance. We're now automating and looking at about 6 different intersections. And again, those intersections are dynamically being changed year over year. So because the system sensors are easily moved, we're able to adapt with the airport growth and the transformation for the airside operations. In addition to the operational system that's also now in the AOCC, so providing all the airside folks with the same view that the tower has, but with all the different systems overlaid on a heads-up display, we also have an innovation lab. So this is where we're able to bring the customer in and cost for ongoing innovation and development of the system, but we're able to actually invite specific teams where they can bring their operational problems to our developers, and we're able to develop technology and actually prototype and test it with live data. At Hamad International Airport, again, a standalone system for a very similar application where we are providing an automation application around the traffic lighting, but we're also inadvertently providing full airfield and apron surveillance as well. Recently, we were awarded a contract with Air Services Australia, and again, part of the national strategy here is looking at remote towers, so taking small airports and bringing them into one center where a group of controllers can actually provide air traffic services to several small, low-density, low-traffic airports. But the first business case was to provide a contingency tower to Sydney Airport. So up here is actually our first proof of concept system, where we're already integrating with all their operational data. The controllers are providing feedback for the operational implementation. And this is a rendering of a control room that can be essentially located within the airport terminal or even off-site, where it could be a contingency and continuity to the business operation. Over the past 2 years, we have also been working with CAS, so the Civil Aviation of Singapore, where they are also looking to adopt the technology in support of their expansion of Changi Airport, given that there's a third runway being planned to be constructed. So they're looking to actually, right now we're certifying the technology. This is a program that also involves certification, training, transition, and integration with existing systems. So the picture here in the backdrop is a video wall, and in the foreground is actually one of the working positions for the controllers, where we are fully integrated with their existing tower systems, as well as the data presented to the controllers. And this is a full customization, ongoing development in terms of perfecting the system for air traffic control of the current operation, which could be a contingency. And then furthermore, once the third runway comes online, they will have a certified digital solution to potentially take place of a physical tower. Over the past 2 years, we have also worked with both the Civil Aviation Department of Hong Kong and the Airport Authority of Hong Kong. Again, looking at the technology in terms of a common system, being able to integrate data from both the airside operations and the ATC operations, but having two separate use cases. Of course, one for the civil aviation, having the technology support their third runway system, which is currently being constructed, and first go live will be 2024. So, and then secondly, the airside operations is bringing that same technology into the airside operation centers, but providing data that, again, is merging airport data and ATC data to support two different operations. And again, by having a digital platform, building out the artificial intelligence and automation applications to support the airport growth. This is a short, actually, video from a news segment that was done in Fort Lauderdale in the United States, where 4 years ago, our technology was deployed instead of building actual apron control towers. So there was a room within the airport operations center that was dedicated to our system, and all ramp operations at Fort Lauderdale, which is one of the top 25 busiest airports in the US, is done in a truly digital environment. But on top of just not being able to, having to build an air traffic control tower for apron control, we're also providing additional applications, like extending the radar and the multilateration surveillance right up to the gate, and providing things like automated billing and feeding the FID system with our data. And moving kind of from the larger airports, this is an airport in Colorado, Loveland Airfield, which currently does not have an air traffic control tower. So we're working with the FAA and the state of Colorado to provide a remote digital tower to be able to provide Class D air traffic control services to a non-towered airport. So we're currently halfway through the project, where the result will be a certification within the FAA's airspace, National Airspace System, where we're going to be able to provide this kind of technology both to airports, the FAA, and private ATC organizations to be able to provide air traffic control services from remote locations. So you're seeing here actually a supervisor position, 2 air traffic control positions, and an out the window digital representation on the video wall. And again, we're integrating with the existing systems, providing an enhanced level of operation to the status quo. And very similarly, what we're doing in Azerbaijan with Azons is providing a single contingency center for all 7 airports within Azerbaijan, as well as 4 different heliports. So again, by going digital, it's a hub-spoke type operation where we're able to open up control services for any one of the 7 airports or 4 heliports from one central contingency center located in the capital, Baku. I believe that's all the time for me, but more than open to any more questions, and thank you.
Thank you, Mr. Pat. We are moving to our next presentation. Let me introduce Ms. Huda bin Said, Airside Safety Operations International Quality Control Manager. She joined Airside Safety Operation International, Incorporated in 2015, holds management position as Quality Control Manager, and manages the Quality Control Department responsible for setting up efficient process, supporting the operation team effort in reaching compliance with international and local regulations. Ms. Huda has proven experience in the aviation industry and was part of various projects in the MENA and LATAM regions. She speaks fluent French, English, and Arabic. She's focused, specializing in airside operation, including supervision, planning, and certification. Once again, Ms. Huda bin Said. Round of applause, please.
Hello. Thank you everyone for being here. I'm pleased to be part of this masterclass session to represent the SOI and to share with you how, in our perspective, innovation in data management improves airside safety awareness and operational efficiency. So I will start by introducing very briefly SOI. We are a focused company specialized in the airside management, and we offer innovative solutions to ensure regulatory compliance and enhance safety awareness on the ground. Today, I'll be focusing more on our data management approach, but for sure, I'll be pleased to meet you later and discuss more about our other services and products. So at ASOI, we are involved in several airsides around the world where we nested fragmented environment with disconnected teams and systems, which leads to a lack of communication and absence of data or sometimes very basic use of it. And our goal is to change this environment to an integrated and more collaborative one, to be able to create a safety culture and improve the use of the data and to transform it into valuable information that could be used using reliable tools. So before even talking about how we do innovate in our data management approach, I would like to talk about involvement, because it's really very important to create trust and confidence between teams and to increase the personnel motivation. Actually, even if we are talking about innovation and new technologies, at ASOI we still believe that's very important to actually the human contact is very important to make people more aware about the importance of their job by collecting data and how important is the quality of that data collected and that will be used later on. And that's why the first step of our data management approach is to inform and coach. Actually, we perform on-site coaching and we explain why data is important for everyone from the bottom to the top of the job positions. And we make sure that we involve the right stakeholders from the beginning to all operational and safety committees, and to support in signing SLAs to engage the stakeholders in providing the required data. Then we identify and define the data. Actually, as you may know, a lot of data can be collected from the airport and the airside, and we need to be selective, and we define since the beginning what's the data that we need and what level of quality is required. And of course, we need to understand and explain the objectives. From a complex environment like the airside, where a lot of stakeholders are there, like operation, airlines, and engineers, it's very important to agree since the beginning on the process and the objectives. So when we have all this, we understand what we need, why we need it, we are able to collect data. And at ASOI, we decided to focus on three main type of data. So the first type is the operational data coming from AIS, that's an invoicing system where the inputs are from FBOs and airlines for example, parking time, traffic, and number of packs. The second type of data is vehicle speed. So we are connecting devices on vehicles with the zone limitation and the speed limitation, and we have all the information about the driver, his ID, the company, etc. The third type of data is safety reporting data coming from our SMS system, which is linked to international and local regulation and SOPs. As you may know, all the airports have to report hazards and have to mitigate hazards related, mitigate risks related to repetitive hazards. So our SMS systems helps our client to report hazards and guides them to mitigate the risks in a standard and consistent way. Our system is on the cloud, so you can use your laptop, your iPad, or your mobile phone to connect to the system. And you have the possibility to take pictures or videos and add them as attachment to be like a proof for the corrective and preventive action. We are also collecting public data from our voluntary reporting portal that's on our website. So if you are passing from to any airport that you are managing, you can directly connect to our portal and report any hazard that you observe. So once we have all the needed data collected, we need to assess this data. So we need to assess its quality, and then we have to analyze it in alignment with the defined KPIs and objectives. Then we create different dashboards that we share with different stakeholders. So if you are a regulator, operator, or investor, and you are managing several airports around the world, you will be able to have a clear picture of all your airports with standardized dashboards with the data related to airside and compare these information and make better decisions. So after that, we can act on results. So with using implemented corrective and preventive actions with the robust follow-up and proof of issue closure. So all this is great, but for ASOI, this is not enough. We are using artificial intelligence to predict hazards based on the airport safety footprint. So what's airport safety footprint? Actually, it's a pattern of hazards that would most probably happen when some conditions occur. For example, based on previously reported hazards and when some methodology conditions are there based on the type, number of airports at a specific time, our algorithm is able to calculate the probability of this hazard to happen again, so you will be able to prevent this incident prior to occur. For example, the graphic here shows a potential higher number of hazards at a certain period of the year where we noticed the peak of traffic. So by using our innovative systems, our clients are not only having access to integrated system, but also are able to proactively predicting and the emergence of these hazards. By identifying the right root causes and being able to effectively focus on other events. So here another example showing that the problem is not the maintenance but the behavior of a driver that's not respecting the process and the speed limitation. And here you can see that the object recognition of the wheels marks confirms that. So to do this, we are working with the innovation community in Montreal and experts in artificial intelligence, such as crime, to analyze and optimize the use of data that we are collecting every day. Because it's important for us to collaborate with the innovation community and to share our learning and then to put together effort for rapid improvement. Because we believe that being able to leverage different perspectives is key for successful innovation. So for ISOI, innovating in data management is definitely helping to enhance safety awareness through reliable tools, transparent and standardized data leading to streamlined aviation regulatory process and allowing you to benchmark best practices. Of course, you will be able to reduce hazards and costs and mitigate risks. And we believe that creating a worldwide airside data analysis center will help the aviation community as one system. And we see ourselves pioneer in this, and we are open to work with all of you to share our mutual innovative solutions for the benefit of the aviation community that we are proud to be part of. So thank you everyone for your attention, and looking forward to discuss with you during the event.
So does anyone have any questions? Any questions?
My question goes to Patty about the remote digital towers. I just want to, for learning purposes, I just want to know the relationship between the new technology with the other equipments that are used for surveillance, such as radar, ADS-B, and ILS. What is the relationship, or how has the new technology linked with these other systems, like radar, for example? That's one part. The second part is, how will the new technology affect training of air traffic control officers? How will the future training be affected by the introduction of the new technology? And the last one is if there is any country in Africa has adopted the new the digital tower currently, if any. Thank you.
Thank you for the questions. Great questions. For first one, in terms of existing technologies, we implement an open platform with an open API. So if there is any data that is currently there from systems, we would look to integrate that data either to augment this kind of out the window view, so provide an enhancement to a traditional analog window view. For smaller airports, for example, that might not have these advanced systems like ground surface movement radar, we're able to provide tracking, surveillance, and further safety nets based on AI and video tracking. That could be an add-on to the system. So the video cameras aren't just for looking. We can process that video and provide, for example, an incursion alarm or even track data on a map. That's for the first one. Sorry, second question was about training? Sorry about that.
I just wanted to learn from you how the introduction of the new technology will affect the training of the air traffic control officers.
Yeah. So actually it's an enhancement to the training because we are able to greenfield towers at airports prior to even that airport opening. Furthermore, we have integrated with traditional tower simulators to be able to actually have the simulated views and simulated data into the actual working position for a digital tower. But again, because we're working with video, we could go and put cameras, even record video from a position where the cameras are going to be fixed. We can replay that video even with existing data and present that to air traffic controllers to already start training them on the actual functionalities of the system and even the views that they're going to expect in the operational system. So it has an advantage. And in terms of deployments in Africa, Middle East Africa, we have a current deployment in Egypt, in Hurghada Airport, where we're aiding with distant operations. So there are some areas within the airfield and apron areas that are actually either invisible or hard to see due to line of sight and distance in the tower. And we're putting cameras much closer to those areas and presenting that information in the air traffic control tower. But we're very eager to have new projects all over Africa.
Thank you.
Thank you.
Okay. Thank you so much for your presentation. I have 3 questions. One for Ms. Huda and 2 for you. Start with Mr. Huda, then I'll give you the questions. Your software or your system, it gives you, through algorithms, the predictability of a hazardous. Knowing the fact in a quality field or science, normally there is root cause analysis, and then the root cause analysis will results eliminations of the underlayers problems. Now, if your system gives you the predictability of the hazardous might occur due to A, B, C, that's give an indication, the initial root cause analysis, it is not state of the art or not good enough to eliminate that problem. Otherwise, it shouldn't appear again. That's a question for you. Take a thought of that, but I'll give him another questions. With regard to cybersecurity, your company is accessing a massive data, which is from ATC, airplanes, and the airdromes or the airports. Now, what you guys doing with regard to cybersecurity? Because I believe those informations can be hacked or tackled, and then either you enter to legal issues in terms of privacies, or critical information leakages about that particular country. That's one for your side. The second one, with regard to the new technology, I don't know, have you guys thought about the unmanned airplane, which is autopilot, or the drone, for instance, which is, well, we don't need a tower, we don't need any more controls because it's all sensed, so it can be running without any air traffics, without any controls. Or in fact, between the airlines, the manufacturer, they will build sensors So the airplane can land and take off without connecting to the airport. So that function by itself, maybe it can be an obsolete within approximately 10 years with the digitalizing or technology involvement. I just need your thought about that. Just need to tell me more about it. Thank you.
So thank you for your question. Actually, the idea is that our system and this algorithm is doing its calculation based on many elements. The first thing is a repetitive report of a hazard with the occurrence of some conditions. So based on that, if a hazard occurs many times and with some conditions, the system will predict this hazard and will define directly the root cause. And once it's defined, we can find the solution and eliminate this root cause, and this hazard will be mitigated. That's the idea.
Well, my question was, you are collecting historical data,
Yes.
and based on certain factors, and the algorithm or the system will predict, depend on history informations.
Yes.
Now, in the initial incident or in the initial hazardous identification, when there is a hazardous, it's been identified, definitely we went through the root cause analysis because of that hazardous. Within the root cause analysis, we came to eliminate the root cause. That's the point of the root cause analysis.
Yes.
Now, if we eliminate the root cause, technically speaking, I should not see it in the future.
Yes, for
So,
sure.
so the algorithm will predict what? Predict something already exists and eliminate it.
eliminated. Yes, but we are seeing this actually in the airports that we are managing. We see that many hazards occur, and even if we are implementing corrective and preventive actions, it may occur again. So because it's the root cause it's not really very well determined. So that's why the algorithm here is doing the calculation and trying to find the right combination between conditions and these hazards, and define what's the real root cause to be really eliminated. Thank you.
Excellent questions. Thank you very much. So in terms of cybersecurity, I guess two ways or two things I'm going to use to answer the question. Of course, cybersecurity policies and data management policies differ from customer to customer. Some of our customers have the most stringent, one of them being Singapore. So one thing we got to make sure is that we are fully compliant and exceeding our customers' current requirements around data security and data protection. The second being on the actual platform technology level, so incorporating the latest in encryption, data security, data management. But in terms of the overall system and ecosystem, yes, we're going to imply the best security and the best encryption, but also having a process and integrating to our client's process for knowing, for being able to know if there is ever a breach, and for having procedures and backups to be able to implement in such an event if it were ever to take place. So treated like other systems, but in terms of our platform, yes, it's granular control and encryption over every piece of data in terms of access sharing and protection.
He is lacking of the the technicality behind it. So I guess as a supplier or as a company, you will educate the customer upfront and tell him the consequences. That's one side. But what are you really doing to protect your data? That's the questions. Latest technology, yes, that's everything is there, but what kind of technology you are doing beside the encryptions? Because there is encryptions is one element,
Yes.
but also there is a hacking or counteracts from evil things,
Of course.
which is may get you in a trouble or dominate the operation of that airport in one side and protect it. I'm sorry, and not protect it, and lead it wrongly and make a problem with that. That's what I'm trying. How you are protecting my data through your system? That's the question I'd like to address.
Okay. On a technical level, I'd be more than happy to provide you an engineering level explanation. But there is definitely layers of protection from everything from how we lock down and harden the system to the encryption pieces to being able to tell if there is a breach of data, and of course having processes around how to deal with that as well. Even you mentioned something from a privacy issue. So because we are using video cameras and things are being logged, we've had implemented, for example, areas that can't be filmed, or putting into the system prevention for being able to even capture what happens in certain areas of the airfield. For example, clients that have a shared airfield with the military. We had to implement certain measures and certain aspects of the design of the system to be able to have that data protection, because there are laws that govern and supersede the civil aviation being the military piece. So we had to prove not only to our customer, to the regulator, and to the third party being the military side as well. But if you want a more detailed technical answer, I'd be more than happy to give you that. We can maybe connect after. We have a little booth over there. And can you...
The second question was related to the evolvement of technology that's making the airplane fly, landing and take off without the traffic control requirements.
And this is reality.
Okay,
right?
so
To give you a couple examples, we're actually working with a company in China that has received the first certification to operate on manned aerial vehicles. So we're actually marrying our two technologies, where we're going to be utilizing, or they will be utilizing essentially general aviation airports as nodes within their transportation hub network, and landing unmanned aircraft with cargo, but in a mixed environment where they're still sharing that airfield with the general aviation community. And we'll be providing our remote digital tower technology from their central operation centers, where they still have a human in the loop in an event that something's wrong with the automated system. A pilot can come in and remotely control that aircraft. And from the same center, using the same facility, we'll be providing the technology to provide an air traffic control service. So we'll be enhancing the level of service at these GA airports, as well as allow the safe operation of unmanned aerial vehicles. To your second point, yes, we are definitely heading to a fully automated world. From an air traffic control perspective, we see where things are going from control to management, for example, where technology plays a key aspect, where certain things that a controller or an air traffic controller would do today will be taken over by the machine. So you've seen an example, for example, that I gave from Heathrow, where an artificial intelligence function is going to be clearing the runway, determining when an aircraft. So that's a big function of a controller today. So we're seeing the evolution of the air traffic controller to become a manager of the operation, where they're relying more and more on technology and automation to be able to handle all the extra traffic that's coming in. So you can't keep building new runways and new towers. It's not exponential. You have to squeeze more out of your current infrastructure, and technology plays a key part in that. And we hit the area now where key hubs are looking at third runway. There's not going to be a fourth. You're going to have to keep sustaining the traffic growth with the current infrastructure and remain competitive, and technology is at the heart of that.